Okay, welcome back. And happy Friday. We made it to the end of another week. One step at a time. What are we working on today? What do you have? Homework 2. Yeah. Any like cool problems or unsolvable error codes? Some Boolean indexing that you just can't get the syntax right. Not yet. Skip down. So the last couple of classes, I know we were looking at like how to plot data and sort of exploring, and then asking questions about like how do we label it and those kind of things. And now plotting. And I saw some people last time looking at some of the Monte Carlo work. Is anyone trying to build solutions with random numbers right now? Or not yet? Okay, we don't have to
Yeah. I have a different question.
Yeah.
Print statement formatting.
Okay, yeah.
How do you print something? Let's say you want to print something in scientific notation. It's a large number. How would you get it to using the curly brackets?
So I think it's one
you want 7 times 10 to the 7.
Yeah, so if x is 13e 13.4321 e12 let's say e7. By default, it's just gonna print out. I'll zoom in so we can see it. Zoom out a little. Yeah, if you use that lowercase e, then it puts it in kind of scientific notation.
Gotcha.
Yeah.
And the one before the decimal point?
That one tells you how many spaces you want it to take up. So if I put 20, gotcha, there's a bunch of white space in front of it.
So if you put nothing there, would it still work?
If you just put
0.2e.
yeah, then it just takes up as much as it needs. Usually you put something there, like a 1 or a 2. Or, I mean, I think 0 is kind of the default of, like, if you put nothing or you put 0, then it just takes up as much room as it needs on this side of the decimal. And then, yeah, then the right side of the decimal tells you like how much space you want to put on that side. 8 is going to use up all those floating point ones.
Gotcha.
Yeah.
Cool. Thank you.
It's going to document that. I think there's like a capital E too. I know there's lowercase and uppercase e, but I don't know the difference between them. I would have to dig into like documentation.
So that's where the 0.2 is. So B forces next to is going to get bigger than the decimal point. So the 0.2 is 0.4, 0.6. Means scientific notation. That means loads. So yeah, so that's pretty good. Yeah, I'm going to start from the project. Okay.
It's your own time for yourself. Really good idea. Yeah, I mean, you submit something and no knowledge that give you a more depth or something. So I would like to then go on and have you wait on for What are you looking for?
I'm looking for the grass on the dance floor. But I haven't gone there yet.
It's silver.
I'll be there probably. I'll see you later.
Next time at your job, come in and lose one day. And everyone's like, hey, what's wrong? Yeah, I'm not worried about it. Yeah. Well, so it's just that it auto updates to 0 if there's nothing, but if there's anything, you know, it just says nothing to show. Then it waits for someone to evaluate. Oh, they're there. Yeah. So that's why I say submit something, that way there's not like a figure out scary. Yeah. So you explain how that whole year part, yes, that's like showing the last the main thing is that right now you're saying you need to be in frame and index it by rather than index it by
What is it? The second part,
So I'm doing the Gordon model. So given set, just move 2017.
This is for part
You start
one.
in the
Yeah, yeah, this is all I need to do, except I'm just trying to print it.
you nest it within the data.
It is literally an issue with the print that I have, too. It's just printed. Like, it's just like, There it is.
When you have a dot format.
Usually box plots are a little different because you can add labels for every step. Like you can label it.
Yep.
It has a list of stuff. Yeah, yeah. Because it's expecting like each chunk of a box is some.
You're only measuring stuff.
Yeah, yeah. Or so yeah, like box plots are a fancier version of like a bar chart. It's displaying the same information, just gives you a lot more like statistical information. Yeah, most of the time every bar chart should be replaced by a box plot, but sometimes you only have one data point, so it would just be one outlier sitting there. Yeah. Yeah.
The mean is the standard deviation. Their standard deviation 0.
That's really good data.
It is good data. Very repeatable. So one thing that came up, I think this is cool, like looking, like how do I, if I know something is linear on a log scale, how do I find the line that goes through that data, right? And this is the same kind of problem that we ran into with like convergence. Like if I want to know if my error is decreasing on a log scale, then how do I find that slope? And really it would be like a least squares kind of regression fit and figure out like, is it order 4 convergence, order 2 convergence, like is it doubling every 2 years or something, or tripling every 2 years? So when, let's delete all that, and we want to say, what did I call it? Not define. Let me run back up, run through this stuff. Get my transistor data loaded up. All right, so my X values, I'll call them like XI, is going to be my date of introduction. My Y values are going to be my MOS transistor count. And if I want to turn them like into actual NumPy arrays, I could say dot values. So if I look at XI, it's an array. It's a array that's one dimensional, so it only has one set of indices, like 1970 through 2019. A lot of repeated years because every row has a year. And then same thing if I look at YI, that's going to be the actual data for the number of transistors and all that. And I think we've already done like PLT dot semi-log y of xi yi. Let's look at stars again. Marker size is 10, just because I like big stars. So if I squint and kind of look at this, I could say, all right, yeah, there's definitely a trend that every year something on a log scale is happening. It's predictable. Seems like it's going along some kind of straight line. So I could just try saying NP, so let's say my fit is NP dot polyfit of xi yi order 1, and let's just plot that. And it's on a log scale, so let's try it. And I'm going to put it as like, we'll call it red line. And it's telling me like polyfit can't do it right now. That's not what I expected, but it's a result. So something about this least squares is just not working already. Didn't converge. Why didn't it converge? I wonder if it doesn't like those missing values. Really doesn't like. Oh. And then how did we do that last time? Call? No. Subset. That's the word I'm looking for. So I'm trying to just get this into the right format, remove the NA values, and see if that, there we go. All right. So it didn't like that polyfit doesn't like those NaN values. That's what I was guessing. But at least now I get a result. It's not the result that I want because it's not a line. Okay. And part of that is that in order to get the data onto this, here, let's take it off the log scale. If I just plot this, if I put it back onto linear scale, then this line is not a good prediction of my data, but it does seem to minimize error, right? So it does seem like polyfit is doing the job correctly, but not doing what I want. All right, so then let's fix this. And for polyfit, really what I want to do is look at some kind of log scale y. So log of that y data, and then do a fit. And then plot that fit. But there's still something off about it. Do you know what's off at this point? Because what I'm doing is put everything onto a log scale. Then I do a polyfit of year versus transistor count, but it's the log of the transistor count, and then plot that polynomial onto there. What's missing? Think about what's missing. Good. I don't want to just like run the punchline. Did you already figure this out? I mean, we have a y-intercept, right? Because we have, if I look at like the output, if I look at output of polyfit, or sorry, this myfit data, below. I see that the slope is 0.34 and the intercept is negative 666. 666, the mark of the devil, the computer taking over the world. Yeah.
So just because you're graphing a linear equation on that log plot, you need to do e to the power of whatever you found relationship.
Yeah. So I went through the process of taking the log of the data and then doing a fit, but I didn't put that fit back into like big numbers again. Like it's still a best fit on a log scale. So instead, what I want to do is also say this is going to be the exponent of all that stuff. So now I'm taking that straight line fit, bringing e to that straight line, and then now I can do like my polyfit result. Now it looks like a straight line, right? Finally got there, a log scale. And by default, log is exponential, like log base e. A lot of engineering work is the default is log base 10. I think we have options for any, like if we wanted, I think we could say log 2, and then we would say 2 to the thing. Yeah, like you could take the log on any scale you want. And the nice part about doing it log base 2 is now I get a result for, because the Moore's law, Moore's prediction was that every 2 years it's going to double. And now on a log-based 2 scale, this says every 0.49 years, it's 1x high, it's 100% more. So multiplied by 2, now it's saying every 0.98, right? 98. I gotta multiply by 2, right? So every 0.985 years, it doubles. Kind of cool. But because I took the, if I scroll up a little bit, and it'll catch up in a second, because I take log base 2, so 2 to the, so every time 2 to the 0 happens every half a year, and 2 to the 1 happens every 0.985 years. But yeah, you can use log, you can use exponentials, you can use 2, you can use 10, figure out like how many years it takes for it to be 10 times more, 5, do something even pi. It would be kind of weird to do like log on a pi scale, like powers of pi, but you can do whatever you want.
He was just like, you can do any log scale. It'll work out. He was like a 2 log scale. Yeah.
Yeah, it's the exact same and then not the
Yeah.
I just don't know it and the commission and then do that.
I think he did something different to us.
I don't know.
I know exactly what it was. It was how he dropped the how he did this. I did differently. No, this is the way. So it's like 0.98. Yes. Yeah. So close. So close. This school may choose the last two.
Trend and you trend of that. For what person?
Really. So I think we do something. Yeah.
Well, not
Oh,
when it starts
yeah.
off with that.
Yeah, I mean, it was so sick.
That's it.
I didn't know what it was.
We had actually one. That's only because the two powers.
Yeah. Yeah.
Oh, you have that? What did you do?
No, let me cook.
Okay, what did you do?
Y base 2 instead of Y base 10.
Is it just literally that? That's just something that happens?
Yeah.
Yeah, it's that's a really thing.
Hey, yo.
Is that the A?
There's mine, but they do.
Bishop the one is two square.
Bishop
Okay.
Is it?
Yeah, I count.
I think so.
That one, a true is the number one. So
Yeah.
false is the number two. So if you look for, so if you sum up all these true false statements, then you get a number that is the number of true statements. They can say like, yeah. There's 9 out of 100. 0.5.
It's because I didn't discuss a thing that actually we discussed.
Yeah, small number one.
Try to move the eyes.
With my eyes look at that's what I'm saying. Everybody's in it. We're gonna hunt it though.
Yeah, I'm really good on it.
Or at least possible. Brand new version. Not really.
It's just so that's
Showing sponsor.
Francesco Carbone.
No, Francesco Carbone. This man showing you IP right now.
Actually, we don't have to sign it.
What's wrong with IP?
Yeah, I think it's Francesco Carbone.
270.
That's another company in intellectual property.
They're showing me the IP.
135.
Just like a master trauma master. Figure bought online.
Yeah.
Actually, it's not
Actually,
even used.
They want to be contract people.
Shut up. I don't know.
Quick, where is source medical?
Exactly.
Okay. So do you know what this man said? This man said about schools and monuments. Oh, schools and monuments. You step up to that again? Yeah.
Or you could just say
I do. It's original.
That's how it was. Yeah, I'm still getting it.
How would they ever stop?
Yeah.
Yeah, that's pretty close.
So I can't do it.
2/3.
What's going on? RFP.
And for Monte
I'm
Carlo,
not transferring
the
money.
meeting figures better. Sure, if you increase 100,
Yeah, well, so
100,000.
sustainability.
That's hilarious. That would just so bad.
It's like a Gaudi pyramid scheme.
It is a pyramid scheme. The epic system so good. Just checking in.
Oh yeah, for sure it was. We don't run out of exclusive.
That shit's on, that shit's recorded now. All of a sudden, it's
So,
so
start coloring the designers.
Literally make sure you go to that.
Using $7.
Why do you want to say color?
Yeah,
That's the third one.
the problem when
Student gear training at the Jordans.
they kept the last one. Designer data. Only given Amazon for the last designer.
Oh,
And
the fourth one wrote the
missing.
year training.
Main things
Because you can,
Well, that one is, but you're semi-log.
well, it's just common enough.
There you are. It's even hard
So,
to university.
it has to improve.
That's all you want.
Yeah,
It's important, huh?
I never said student because I put those in these.
yeah, the title and the labels, you can.
Students.
So if you go in, you're not gonna hurt anything, it's just doing
Yeah,
unnecessary.
Okay, so each time it's reading it, plotting it basically.
Yeah,
Okay.
and so what you're finding is that when you do a for loop, that variable that they assign inside that for loop, it keeps getting overwritten
Yes.
until the loop is done, and then it gives you the
Well,
last
that's
value.
okay. So by doing all of the loop, it's gonna plot each one as good.
Yeah, so if you want things to change as that variable changes, then you need to keep it in.
Okay.
Somehow.
That makes sense. Thank you.
Yeah.
Why?
And then the thing for the project was that it's good. Oh, just
Yeah, I'm going to ask them.
here, just like double click and add
Build it.
.md that thing like that.
Where is it?
Analyze data. Inside that parentheses. Dot. Oh, sorry. And then, and mark it down. Yeah, some of that. And then, yeah, shift enter.
I will post this second quiz. Tell me that's cool.
Yeah.
Just as asking. That's how much love that.
Yeah.
He said, I find that. But I know his dad's saying this and.
Oh, coming up on the weekend. Cool. And we got some time. We're just talking. I think next week we're trying to wrap up homework number 2, then jump into project. All right. Have a great weekend. Thanks so much.